This is Julian Seegers for the How Are You Doing lab, where we're going to be looking at an endothermic reaction by barium hydroxide and ammonium chloride. And then we're also going to be looking at an exothermic reaction through the use of calcium carbonate and sulfuric acid. So at the beginning of the video, we see her, she's setting it up. She's discussing like what I guess her procedures. So she uses a flask, she has her wood block, she has her barium hydroxide, and here, let me show you. I've already written it out. She uses barium hydroxide and ammonium chloride. She's mixing them together. She doesn't give us like an exact mass, and you can see that in the video. She kind of just pours it in, right? Right, she doesn't measure it. She just kind of pours in a general amount. So as far, I guess she's not going for like precise measurements. She's kind of just going for the overall reaction. So what's it called? As far as the chemical equation goes, you have barium hydroxide and the ammonium chloride, right? And I'm pretty sure this is barium chloride. And you see it gets broken down to water, and I'm forgetting what this is, nitrogen, hydrogen. So I would assume nitrogen hydroxide, possibly. I'm not fully sure. But you see it gets broken down, which is the main point. So throughout the video, we see here, she prepares the barium hydroxide and the ammonium chloride. She pours out a general amount to each separate container. She prepares the water on a wood slab, right? She has water, she has the barium hydroxide here alone, separate. She hasn't mixed them yet. She pours the two substances into the same container. So we're about to see her do that. So she takes the general temperature. So here she's pouring it into the container, and it's going in. And now, as she mixes it, we're going to see a very, very steady temperature drop. And this is a rather quick reaction. So the water is going to turn to ice, and the temperature is going to decrease very quickly. See, we're already at 4. It was at 6, 4, 2, 1. Now we're in the negatives even. And so I even have a chart to replicate this. So with the endothermic reaction, right? She started at 23.4, a rather stable temperature, and then immediately, as soon as she started mixing it, just at 1 second, it dropped to 6 degrees. Like, that's insane, right? So you see this huge temperature drop. Now it's complete vice versa. It's the complete opposite for the exothermic reaction. So I'll speed up to that. So with the reaction here, I'll go to not the exothermic reaction yet. You see, we're going even more negative. And what's really interesting is whenever she picks up this container, you're going to see that it's stuck with ice. So when she picks it up, this has all been turned to ice now. So this wood slab is literally frozen to this cup. See? So that's an endothermic reaction, completely froze. It sucked the heat in, creating a very cold temperature. Now the exothermic reaction is a lot different. We're going to see a more stable increase in temperature, complete opposite of the endothermic reaction, because this one creates heat instead of absorbing it, unlike the exothermic reaction. So what we're going to see her do, she's going to mix calcium carbonate and sulfuric acid together. So see, she already has her calcium carbonate. She's pouring that in right now. When is she pouring the sulfuric acid? She's about to do that. So see, right now we're at a stable temperature, about the same as the beginning of the endothermic reaction, 22 degrees. So now she's going to add sulfuric acid. And we're seeing all these bubbles form. And so as these bubbles are forming, those are heat bubbles, because the temperature is increasing steadily. So now she's going to return back to, when she turns back to the LabQuest screen, you see a very stable, see how it's already going up. 39, it was just at 22, and now we're already at 40 in just a matter of seconds. So you can see how quickly these chemicals react or these substances react when they're put together. So I've even mapped this out. So this is the endothermic reaction, right? We start at a stable temperature, and then it just drops substantially and steadily kept on dropping, even into the negative degrees. The exothermic reaction is different. Here, we started off at a rather stable temperature, right? And then it just went up like crazy, right? As soon as she added sulfuric acid, right? This is just time in seconds. So, I mean, I would guess what's the biggest increase that we had here? I'd say probably here between 1 and 2 seconds, it went up about 1 to 2 degrees. So I'd say that's rather proportionate. Per second, it goes up a degree or two. So what's it called? As far as like her procedures went, it's kind of the same thing. I'm pretty sure in this video, the lady's just trying to get a general understanding of like how the reaction works. She wasn't really going for like specific like measurements and calculations to determine something. So here, all that she really did, she poured a general vary amount of each substance into individual containers. Then she stuck her lab quest in to, get like a stable general like beginning temperature at 0 before she mixed the two substances. Then she put the two substances together, and then we begin to see this rise in temperature occur. What's it called? I've mapped this all out, and then I think this is probably the best photo. Let me see if I can find her photo in here. All right, so this is just the aftermath, and you can see how all the bubbles have subsided, so there's no more bubbles anymore, and now you're just left with this excess of very, very hot substance. And so I think this is a good video as far as like proving like the differences between endothermic and an exothermic reaction. Endothermic, it absorbed the heat, giving off what's it called? I guess it absorbed the heat, giving off a decrease in temperature, right? Because since there's no heat, it's obviously decreasing in temperature because it's getting colder. The exothermic reaction is complete opposite. It releases heat instead of absorbing it. So because of that, we just see a very steady increase in temperature. And so I think this goes to show how varied substances can react quite differently.